solve this system, x plus y is equal to 11, y is equal to 2x minus 1. So I'm going to take this expression for y from my second equation and substitute it for y in my first equation. When I do that, I have x plus 2x minus 1 is equal to 11. Notice that I've eliminated the variable y from this pair of equations. This equation has only x in it. I simplify. I have 3x minus 1 is equal to 11. Add 1 to both sides. 3x is equal to 12. So x is equal to 4. The x-coordinate of my point of intersection, I'll take that value of x, put it back in here, and get y is equal to 2 times 4 minus 1. That's 8 minus 1. Y is equal to 7. So the solution to that system is x equal 4, y is equal to 7. That's the only ordered pair that satisfies both this equation and this equation. And if you were to graph these two equations, you'd see they would intersect right at that point, 4, 7. Our next problem is 2x plus y is equal to 1, x minus 5y is equal to 17. Let's start by taking this equation right here and solving it for x by adding 5y to both sides. X is equal to 5y plus 17. Now I'll take this expression for x from this second equation and substitute it for x in my first equation. 2 times 5y plus 17 plus y is equal to 1. I've eliminated x from the pair of equations, and this is what results. Distributive property, 10y plus 34 plus y is equal to 1. 10y plus 1y is 11y, and I'll add negative 34 to both sides, giving me negative 33. Y is equal to negative 3. That's the y-coordinate of the point of intersection. Let's take that y and put it back into this equation right here to get x minus 5 times negative 3 is equal to 17. That's x plus 15 is equal to 17. Add negative 15 to both sides, x is equal to 2. So the solution to this system is x equal 2, y equal negative 3. And that is the only ordered pair that satisfies both of these equations. Okay, we want to go now to one last example and see what we can do with it. So I have 7x minus 6y equal negative 1, and x is equal to 2y minus 1. I'll take that value of x, put it back into this equation, and I have 2y minus 1, that quantity times 7, minus 6y is equal to negative 1. 14y minus 7 by the distributive property, minus 6y is equal to negative 1. 14y minus 6y is 8y, is equal to, I'll add 7 to both sides and get 6. Y is equal to 6/8, which is 3/4. Y is equal to 3/4. Let's put that back in here and end up with x is equal to 2 times 3/4 minus 1. 2 divides into 4 twice, so I have 3 halves. Minus 1, that's 3 halves minus 2 halves. I end up with 1/2 for x. So the solution to that system is x equal 1/2, y equal 3/4. And again, it's the only ordered pair that satisfies both of these original equations, and we solved it by using a method called substitution.